understands, and like you don't have to fully understand this. If you want to do more of your own research into it, that'd be good. Like, but before we get into actually web developing and getting into web development in general, I think that personally it's important to have a little bit more of a fundamental knowledge about how it all kind of works to begin with. And that's why I am starting with just an overview on socket connections, how socket connections work. Now, because the end goal here is for everybody to be working on ABUFs, you're going to be doing a lot of actual work with socket connections and server connections. So it's extra important for you guys to really kind of understand what's happening behind the scenes. And some of you guys will be able to relate this to things that you kind of already knew, but didn't, maybe you just didn't know that that's how it worked, because anybody who uses the internet nowadays, you're constantly seeing these things, although you might not really have a good idea of what it goes. Now, I was going to, when I started planning out this whole entire session for today, I actually was going to go into even further down into the infrastructure of how, like, even like the internet kind of laid out. Not a historic lesson, but just talking a little bit about dial-up DSL cable. But then as I got further and further, I realized I do want to keep this between 1 and 2 hours, closer to the 1 hour than the 2 hours. So I decided I am going to cut out a lot of what I wanted to talk about infrastructure. Personally, I find it super interesting. So if anybody else wants to ever learn about it, like, we can either talk about it offline, or you can just do a little bit of research, but I think everybody here's aware, started as a dial-up, but then, DSL is something that AT&T started doing. Like, we're not going to get into a whole lot of detail about how that worked, but today, like, most people are shifting to using fiber optic connections. And I think the one thing that I'll just mention about is, even if you're connecting wireless to like one of those hotspots, wide hotspots, everything is still going through, the infrastructure underground. Everything goes through cables in the end of the day. And it's starting to change now with like satellite internet being a big talk, and I'm not going to get into detail about that. But ultimately, just kind of like what happens in between before the connection gets to your home, which it's a good segue to kind of talk a little bit about how we're going to, how IPs are assigned, what IPs means, and this is the beginning to kind of somewhat understand how socket connections work, right? So in this diagram, we're going to use an analogy as an example. So we're going to basically look at an IP address as like the actual address of a neighborhood, not the address of a house, like an individual house address. But if you have that physical mentality, okay, so if you're driving to somebody's house, you get directions, you go there, you're going to an address, right? And nowadays you can like put that in your GPS and it takes you straight there. So that is how you know how to get to that house. For the internet and the way that signals will travel to your house, it's kind of like the same concept, but instead you have an IP address, and the IP address is how that connection is able to be routed to your modem. And so that everybody with me so far, right? I just want to make sure, as before I move on, everybody kind of understands the analogy and the reference between how an IP address can be similar to an address.
Yep.
Yeah.
Okay. So now we're going to look at it as like a neighborhood, though, because so once you connect to your router, and I know that nowadays everybody's got a router, because you can have your phones or your printers and your multiple laptops all connected to the same network. So your local IP, like if you were to if you use Windows and you go to your command prompt and you type like ipconfig, right? A lot of you are going to see, now for me it's a little different, but don't worry about my setup. This number is going to probably be 192.168.1. something or 192.168.0. something, unless you're in a VPN or unless you've changed your configuration. That is the typical IP that you get. Now, this is not your actual IP address. The IP address that your computer has is your local IP address that only your router knows about. So that number doesn't really mean anything to anybody beside, like, unless it's somebody in your network, if that makes sense. Somebody who's connected to the same router. So your router would basically, that last number on your router would change depending on what the device that's connected to it is. And we can kind of look at that and think about it as like different homes in that neighborhood would have that different address, right? And that's kind of like how that works. Now, if you were to go to any website, or like, there are ways to do it with CMD as well, but it's a lot simpler to explain if we just kind of use a website as an example. So like IP Chicken off the top of my head, if you go to ipchicken.com, IP Chicken tells you what your actual IP address is. So this is your global IP address that that's how the internet knows you. Like, so if you were to do that on your computer, again, unless you're connected to a VPN, that is your global IP address that it goes into. And we'll talk a little bit about VPNs too, but just for the sake of everybody having a full understanding of how all this stuff works. So once you're connected to your actual computer, this is how this is a good overview of kind of like what it looks like. So this blue IP here would be the global IP. Now this IP this is not, I think this is Google's IP. I don't even remember where I pulled that IP from. Maybe I just randomly typed it when I was doing this. But so you have your network IP range, and then every device in your network will have its own individual IP address. I'm not going to get into high detail, but like, if you wanted to choose an IP address for your computer within that range, you can configure it that way. And when you're running servers like I do and you're hosting services, you have to actually know at all times what IP address for each different machine, what they are going to be, because that's how you're able to like reliably host a server that's always going to feed the connection to where it needs to go. And that is, again, and we're going to go back to this screen a lot as we're talking about socket connections and how everything works. So then the next big analogy here that'll kind of help you guys wrap your heads around how port transactions work is to look at, so I kind of created, so let's say that one of the addresses goes to like a hotel, even though this looks like an apartment, but I couldn't find. I was trying to do it quick, but say that this is a hotel, right? So then your local IP address, say it's 192.168.1.45, and again, this is just your IP address that's local to your router. So every computer, every IP address can go through up to 65.5 thousand port numbers, right? Now, port numbers is not something that you really see in like, you know, everyday computing. Maybe, I don't know, if you've like hosted games that you needed an IP to connect to somebody, you might have like seen that you have to choose a port and all that. But ports are actually a very important part of how server to client communication works. And part of the reason why we're going to use the whole hotel room as an example is to kind of explain how your router knows where to send that connection. So so now you have the address, right, to get to that building, but that building can have many services, in this case servers, running that you need to send a connection to. And in English it's called port. In most other languages it's porta or puerta, which actually just means door. So even like the way that it was defined and the way that they decided to call this was kind of based on the same kind of idea, where every number is basically like a door number. So think about like if you're walking through a hotel hallway, you know, you have your first floor, second floor, third floor, and it usually will go like 100 to, I don't know, 150, and all those rooms are on the first floor, et cetera, et cetera. So every room has its own, every door basically has a number, and that's how, you know, if you're going to visit a friend, when you get to the front desk, you have to find out what room they're actually in before you could go visit your friend. And there's like a ton of other people in the hotel. So we're going to look at all those other rooms as different services that could be running on your computer. Now, by default, when you have a router connection, and I'll just kind of show you like a real life example. So this is like my router setup. Shit, I don't think I remember my password off the top of my head. I'm not gonna actually go over it, but basically, by default, ports are closed. So anybody trying to connect to your computer won't actually be able to make a connection anywhere because your router doesn't really have any open ports for it to go to. So, like, so say for instance, right? So now we have that address, right? So say I want to go to this address, and for you guys as all know that this is Dynamic D. So for instance, if I ping dynamicd.com, the domain, and I'm not going to talk about how this works, how DNS. That's not about to. I don't think we need to go over how DNS works. But so your DNS server, which is in your ISP, your internet service provider, knows to translate the domain to the IP address. So as you can see, even though I put in dynamicd.com, it knows to go to my IP address, right? And that's going to be the same for pretty much any domain that I host, like ABUFs. It's all they all point to my server. I can point them to whatever server I want. But the reason why you can go to dynamicd.com and actually pull up a page that I'm hosting on my server is because once you go to dynamicd.com on the browser, it knows to go there. And we're going to talk about how it knows to go there in a little bit. But we're talking about ports, right? So having that IP address, when you enter the IP address, like, so address, I'll just do it here. So you do address like 98.27.11.80, and then you put in the port number. Your router will then, like, basically take that port number, and I think we can go back to this screen real quick. Your router can take that port number and be like, okay, so you've configured port 80 to direct to 192.168.1.6, right? So it'll basically go and reroute that connection over here. And then this computer will basically be the one getting that connection. Although there's a ton of other devices on your network, that is how it gets to the specific computer. The router basically needs to tell it where to go, right? So what happens when you go to a website, like you go to google.com, how does your router know that it is your computer and not like a phone or a printer or anything else on your network that's supposed to be receiving all this information from Google? So basically, and I'll try my best to kind of like explain how it works. So when you send a connection to google.com, we're not going to talk about what the server does, but when your router sends a connection over to the server, on the router level, what happens is it'll choose a port. A lot of times it's random, but this really depends on your router. It'll choose a port to be a relay port, and this port, it's usually a high number, like 2400 or 245 something or whatever, as an example. It's going to be a random port that it randomly picks. It'll basically send that connection, and it'll keep waiting back. So with the connection that went to the Google servers, it's basically listening to receive something back on that port, knowing that that request came from your computer. So then once you get something back on that relay port, it knows to just relay that information right back to you, and then it'll load google.com. And in the end of the day, when you're like just accessing a website, you're basically initiating a socket connection on port. Well, if it's HTTP, it'll be on port 80, right? So you initiate a socket connection to Google on port 80. It responds with all the information that your browser needs to know in order to render all of this, and it's gonna look like this basically. All of that kind of comes back from Google. That's the data that comes back from Google for your browser, and then your browser uses this data to render the website for you. So that's essentially how the socket communication happens. Now, if it's HTTPS, it uses port 443 instead automatically. Now, your browser, whether you're using Edge or Google Chrome or Firefox, anytime you go to a domain, it knows by default it's using port 443 if it's HTTPS, and if you do HTTP, like a lot of servers, like Google servers, will reroute you to HTTPS. But if you HTTP will be port 80, HTTPS will be port 443. You don't need to remember these ports, But these are the only ports with web development that you're really going to be dealing with at first. But once we get into doing connections to the game server, we'll be just choosing whatever ports those connections will listen on, right? But so those are the two differences. HTTPS goes 443, port HTTP goes to port 80. Now the difference between a secure connection, HTTPS, and HTTP, for those who don't know, maybe you already know, maybe you don't, it's essentially the same thing, but there is a like any modern browser nowadays, like for the past, I don't know, decade or something like that, as long as I'm not even sure when HTTPS became a thing, but the connection is encrypted. So the signals going back and forth are encrypted using like a key that's kind of like how do I explain it? Let me think off the top of my head. So it basically just uses like a global service where like they register the credentials, and that's how you're able to encrypt and decrypt the information. And to everybody else, because connections are so quick nowadays, it doesn't really make a difference, like, you know, in as far as like speed goes. You still get it within 100 milliseconds almost anywhere, especially going to a popular website. And the information, the difference is it's encrypted. So if you have, like, for example, somebody who pulls up in front of your house and manages to hack into your network, and they start listening for everything that's all the connections that are happening, all the socket activity that's happening on your router, HTTPS, they're not going to really be able to decrypt that, because all the packet information, and packet information is really just the information going back and forth on your socket line, is going to be encrypted. So they're not going to be able to do anything with that. But if it's an unsecure connection, port 80, and you, for instance, say you send your password over because you're trying to log into a website, they can actually sniff that out. And it's due to attacks like this and like people's credentials being stolen like this that HTTPS became a thing, and now it's like required pretty much. Like any modern browser, if you go to an unsecure website, like if I go to DannyPups.com, which is a website that I host, but I haven't set up SSL for it, this is what you're gonna see. Like you can go to it, like Danny Pups, I'm pretty sure. Hold on, ping DannyPups.com. Just make sure that that's actually something that I'm hosting. I could not be. Yeah, it is. So that's another domain that I own, and it's basically like I don't have I'm not actually, it doesn't, there's nothing there right now, right? But it's still pointed to my computer. So because I don't have this set up, your browser is going to tell you that it's not private and it's unsecure. And nowadays, honestly, if you see this and it's a website that you're not familiar with, you probably should not be going to that website, unless of course you don't plan on like logging in or putting any information on it or whatever. But that's the major difference between HTTP and HTTPS. When you're dealing with WebSockets, it's the same thing, you know, but that's essentially all it is, if that makes sense. Now, going back to the whole concept of ports, right? And I just want to make sure that everybody kind of understands what that means. So that is how, like, port numbers is basically how your computer knows what that connection is trying to get to. So say for instance I host a server on my server, and I've got a mail server, I've got like database servers, I got web servers, etc. Only the ones that go to 443 or 480 or port 80 are the ones that hit my web servers that are running, and then those servers send back whatever information that they need. Now, I know this is a lot, especially if if it's all brand new information for you guys. So I'll go ahead and just open up the floor for questions so far as we got here. Does anybody have any questions at all about everything that I just explained? And if I don't hear anything, I'm just assuming nobody has any questions. Okay, good. All right. So we can move on. And we're getting through this a little fast. I actually expected people to have questions. I'm kind of surprised that nobody has questions.
Do you want me to make a question?
No. I mean, I'm either explaining it very well, or you guys are not understanding shit.
So when I hosted a server, because I used to host servers for games,
Right.
when I port forwarded my router on the port 25565, it's like basically opening a door for people to connect through my router to me or to my
Exactly.
game server. Okay.
Exactly. Yeah. So like so I think everybody in this call is familiar with what a DDoS attack is. If there is nothing for a DDoS, like typically when somebody tries to connect to your address and they're trying to connect on a port that's like not being listened to and it's blocked by the router will just straight up reject that connection. The connection literally doesn't do anything at all. So if somebody just having your IP address is not good enough for somebody to do a DDoS attack against you. However, if you run like Microsoft services or if you're connected to a game like Arc, then Arc always uses the same ports to relay information back to you, and so does Microsoft services. So they're able to just target that port because as we talked about earlier about how your router chooses a port for that connection, so that when you send the signal out, it knows what port to send it back to. Those ports can be used, like if the person doing the attack knows what you're running on your computer, like they know you're running like a Microsoft app or they know that you're running Arc or whatever, they can target the ports that they know are going to be open and then basically just flood your network with connections. So it's basically just all it does is fill up like your queue of requests at a ridiculous rate so that your internet can't function normally because there's so much to go through. And this normally what happens if it's just a little bit, well, like a weak DDoS attack will just slow the shit out of your connection, but like a really good one will literally render your router useless, sometimes even crashing it. And that's what a DDoS attack is. I hear brass.
Yeah, I'm here. I'm just.
Okay, I wasn't sure if you were gonna ask something or not. Like, if something makes a noise, I just want to make sure you're not like making a noise so that you can say something. Sorry about that.
No, yeah, I'll definitely make the noise of going, "Yo, stop!"
So that is more or less how ports work. So like so now I'm just gonna go ahead and switch to my little diagram for like give or take socket. So this is probably the last thing we're gonna sit on here, but we're gonna talk about a couple of different things that just to make sure that everybody kind of understands how it works, right? So a client and a server essentially are just two computers. Like the only difference is when you're connecting to like a enterprise server like Google, instead of looking more like mine where I just have this one little server machine sitting next to me that's kind of like a computer, Google servers look more like this. It's a ridiculous like in industrial building, that has like stacks and stacks and stacks of these racks to kind of share the load and like pretty much process everything as fast as possible. For me, like one of these little racks here is all I have. That's how our server looks like. And if we ever get to a point where any one of our projects like takes off and we need to expand in order to like fit the capacity, I'm not going to like start expanding my hardware in my house. At that point, that's when I just kind of shift everything over and I'll just pay to use Amazon Web Services or something like that, where you're just letting them scale and you're just kind of paying for the service. It makes sense to do it if the money that you're spending is like obviously significantly less than what you're making in that kind of case. But yeah, so that's how that looks. So then to kind of give you guys an example of like the whole port thing that I was talking about. So this is within my local network. So if you guys try to go to like 10.66.60.205 on your end, nothing happens because your computer has no fucking idea what that means or where that goes or what that is. But for me, because I am connected to my own network and this is what my range is, if I go to this website, so what's happening here behind the scenes, I'll kind of pull up I'm going to pull up the way that my servers are set up so you guys so I could kind of give you a better explanation of what's happening, right? It's 10.198. And I'm not really worried about the fact that this is live because my server is tighter than a microbe's butthole. Like I have no ports open at all. Like nobody could really connect to this stuff unless you're in my network. You don't have access to any of this. But anyway, so these are all the virtual servers that I run, right? The only server that listens on port 80 is Dynamic Web. So Dynamic Web, when I send the request to 205, well, 205 is not web. 205 is dev. So like right here, you can see this is the IP address 10.66.60.205, and this is like basically what the server looks like. It's just a Linux server, and we're gonna get into more about that in the future. You guys are really not gonna have to deal with Linux too much at all. I hope not, anyways. I'm gonna try my best to make it so you don't, because you can get away with using Windows Store for just about everything you need to do. If any of you guys pick this up, start picking things up a whole lot faster than everybody else once we get to the programming stuff, then I might bring you into the Linux side of things a little bit, because you might be useful as a sysadmin to help me keep things up to date. Like, for example, all of these machines need to upgrade the Ubuntu operating system running on them. But every single machine, as you see, has like a dev version. So the way we do it is like, so say I need to upgrade my development server, we'll start by upgrading this first and testing it and making sure that everything works here, and then once everything is clear and good to go here, then you can like mirror it back here and make it live, so it's very safe. Like, we're never gonna like take something down and fuck it up where it doesn't go back up or anything like that. So everything that anybody does is safe. I'm pretty sure that what I'm gonna do for you guys, like once you get to the point that you're actually developing, I'll create a new version of Dev, just because I use this one for my actual day job. So I'll probably make a copy of this one and I'll just call it Dynamic D Student, and then anything that you guys are working on will go through that one. Just because that way, like, I don't have to worry about the load on this one. This one stays free for Kadri and for myself and for anything that I'm doing here, and all the servers that I run here, because I run plenty of servers here. So anyway, I kind of got sidetracked a bit. I apologize. So when I go to 10.66.60.205, that connection goes to my router, and then from my router it goes to my other router. I'm just skip that, forget that. But then my other router sends it over to this machine, Dynamic D Dev, and then Dynamic D Dev. I have a web server that's running. It's called Nginx. There's several different kinds of web servers. You can run one on Windows too. Like, you can run servers for just about anything, but the one that we run for all of our web solutions on Dynamic D is Nginx, and then Nginx is able to take that connection and route it over to where it needs to go. And right now there's nothing happening. It's just this, right? But then if I go to port 4200, this is basically going to my local BTCU. Now, this is not going through Nginx. This is going through an Ember web server that I'm running right here. So this little thing here is basically just running my Ember service. Like, so you guys are gonna, once you get into working with Ember for ABUFs, which you will, you're going to run something that looks like this, and you'll be able to just use localhost and then whatever port to connect and test your work locally, right? So that's essentially what I'm doing, but instead of doing it locally, I'm hosting it on my server, so I can connect to it using this port, because this is the port that it's running on. And again, it's just the browser by default will go to 80, so if I go to 80, it's going to go here. But if I go to 4200, it goes to the other one. And the ports is basically how you're redirecting that connection to the different services that are running on whatever the computer is that's hosting those servers. Hoping that makes sense. And then, so the idea of a client and a server is another thing that's important to understand. When it comes to web development and visiting a website, I'm going to just ask a question. Does anybody know what the client is? It's your computer, but what is the application running on your computer that is technically the client making the request to the server? If you know the answer, just go ahead and say it. If you don't know. No? Okay. So your browser, basically. In this case, in this example here, it's Chrome. Chrome is the client. So anytime that you're thinking socket connection, like you get used to the term client and server. If you are connected to a game like Rocket League, your client is the Rocket League application, and the server is the Psionic servers that you connect to for just about everything. You're gonna also hear the term like get request or making a post request or making a request. So here I have an application called Postman. This is an application that you will all have eventually because you're gonna need it. But this is an application to test get requests. And get requests are essentially it does exactly the same exact thing that your browser does. The only difference is a get request doesn't necessarily expect to see a full web page. It's just getting back information. So like on just about any, I'm trying to think of a website off the top of my head that you guys might be familiar with. Let me think. Do any guys know a website that like updates itself? Any website at all? Any example of a website that updates itself? Like that you're seeing information and the information updates itself.
Like a weather or news.
Okay, so like weather.com, right? So weather.com is going to, well, that's a bad example. Well, okay, maybe this does update itself, I don't know. But when you pull up your development tools, which is F12 is like the hotkey for it, and you go to network. So network is basically showing you every little thing that this website is doing, like all the information that it's pulling. Now we're more interested in Xhr requests. So Xhr requests are all the requests that this website is making to kind of like get information while it's already running. And when it loads, it usually will run Xhr requests for things as well. So like, I'm just gonna refresh it. So all these Xhr requests that we're seeing here is basically the website pulling information from a server to populate what you see on the page, right? And I'm gonna try to just pick a random one here. So like, I don't know what the hell this is because obviously I'm not familiar with this website. But this is a get request to a JSON file. And a JSON file, which is again something that you guys will learn more about later. But if I take this request and I just directly go to it on my browser, this is going to give me like just a whole bunch of information. So the website is able to take this information and then parse it to show you what it needs to show. And you guys are going to learn how to do this, because you kind of need to especially nowadays, like back in the day, like websites did not use Ajax requests for anything. That's what that's called, an Xhr request. But because, modern, you don't want people ever have to refresh the website for anything. You want to make sure that anything that you want to update, or even when you're like pulling, like, so this ad that they pull, this is likely going through a different service where that determines what ad should show up. So it's probably an Xhr request on that list that goes ahead and pulls what information it needs to show for this little box, and then it populates that box when it gets the information back. And all of the coding that happens to do that on every website in the world is going to be JavaScript. It's all JavaScript. Everything that you see here is rendered by using HTML for the markup. It's styled by using CSS, and everything functional, like what makes this button, all the buttons do what they need to do, or what makes this search box work and all that, is all just JavaScript code. And you guys are going to be learning a lot of that. Now, JSON format, if I use Firefox instead, personally for development, I believe that Firefox is just a much better browser. I also use Firefox Developer Edition. You guys don't have to get it yet if you don't already have it. You actually don't need to get it at all if you don't want to. Like, I'm not about forcing people to use the same tools that I use for things. But from experience,
we'll just make our own. We'll just make our own decision with all the experience we have.
No, well, here's the this could get into a whole thing here, but it's like, obviously, like, I'm not, just because I have all the experience that I have doesn't necessarily mean that all the tools that I use are the best tools to use, right? Just because that's what I do. I am the type of person, though, that it's important for you guys to know this. I'm the type of person that I'm all about doing things more efficiently and quicker. So if you tell me a way that I can do something that I always do faster than I currently do it, I'm going to be all in on learning that new method of doing it, right? So I spend a lot of time every now and then. If I feel like something is taking too much time to do, I always try to find a better way. Now, like you can see the difference. If you're trying to just pull up a JSON file to look at the information, if you're looking at it on Chrome, I mean, this is not really legible. You have to like copy and paste this into a JSON parser so that you can kind of see it kind of like this and kind of make sense of the information. But because Firefox by default acknowledges the JSON file, it will automatically go and give you all this nice. This is all the browser doing this. Like, this is what the server's sending you. But then Firefox has some tools to go like, okay, this is a JSON file. Let's actually go ahead and break it down. So these are the headers. We'll talk more about one of these days. We'll talk specifically about GET requests. I don't want to turn this into that, but you guys will understand more about like how a GET request is formulated. Probably the next time we do this. And then this is the raw data. So this is like the same thing that you see on Chrome, right? This is the raw data. But then this is the JSON parsed version of it. So like now you can actually somewhat even though we know nothing about this JSON file whatsoever, I'm seeing it for the first time in my life, it's a little bit easier to understand what's going on here. So this is the currency, skip rate, schema version. So this is just like, and then timestamp. So this is just kind of like setting up the file, and then model groups. This is like a whole bunch of different groups. And this is an array, and you guys will learn more about what that means too. I'm going to try not to kind of sidetrack too much. So this is an array of information, and each element of the array has like a whole bunch of different information. And I guess that this is just kind of, I'm assuming that this populates like one of their weather tickers. Because now here you see like all this shit, you know, it's just a bunch of values. I don't know what it does. I don't care what it does, but with Firefox, like, let's pretend that you're actually trying to like debug a problem on a website, and you have for a client, but you don't really know the infrastructure of their website. It'd be a lot more useful to use like Firefox to like look through their GET requests than it would be to use Chrome. Although Chrome for performance is definitely a better browser if you're just using it to like play games or watch YouTube or whatever. That's why I have both. Like, I actually
Can
use both.
Can you send that link, please?
You want the JSON link? Sure.
Yeah, please.
I'll go ahead and paste it on discussion. There you go. So that's what that is. And in a GET request, again, to just kind of like take a step backwards. So the GET request, like, Postman is a client to do GET request. A GET request is not just to receive information. Xhr request could also be used to post information somewhere. So like we could do, like, for instance, I can do a post request. There's all kinds of different requests you can make, but we're just going to focus on get and post. We can do a post request to a certain URL, and then we can actually send information. Like we can say like name, stone, and I don't know, ID 1, and like, I don't know, a key, and then there's like some random key. And we can use this to like make it so, like, say for instance you're submitting like a form on a website to save something to the server. That's how you would do it. You would send a post request, and then the server will go and take that request, and it'll get all the data that you sent to it, and then using whatever code that the server's coded on. Now, a server could literally be anything. You could have a JavaScript server that runs on Node. You could have a PHP server. You could have a Python server. You could have a server that's running on C#. What they run on is irrelevant. At the end of the day, is just you're sending the information to that address. How they decided to like listen in and code whatever information they receive is up to them. So that's kind of like goes into a little bit about the magic of like the whole web development world and why there's so many different languages and different services, etc. Because there's so many different ways to do something. But again, for the purpose of ABUFs and for the purpose of us, we're always going to look and think of everything in terms of JavaScript. So if it's JavaScript taking this information, then the block will basically just kind of look like a JavaScript block, which I can kind of very quickly, without sidetracking too much, show you what I mean. So anything that you write on this console here. So if you open up your development tools and you go to your console tab on any website, everything that you write here is going to be JavaScript. So if I make a variable called object, and like I'm not going to explain like the syntax here, we'll do that a different day, but I'm going to make some keys, the same keys that I just created on Postman. So I'm just going to some random key, and then ID is 1. So this is my object. So now I defined my object for JavaScript, right? So this is my object. And if I alert the object, you're not going to get any information on the website. But if I alert a property of the object like name, you're going to see stone pop up. You know, so using JavaScript, like this is how JavaScript would kind of go through all that data to figure out like what you need to do. So like if you look at that ticker that we were just looking at as an example, shit, I closed it. But if you look at this ticker that we were looking at, there it is. So say that the whole all this data here is just data, right? So data is all that data that's in there. If I wanted to just, all I wanted to do is just get what the currency of it is, then I would do like data dot currency. Now, of course, this is not going to work here because data is not actually that information. But I'm saying hypothetically, if it was, you know, that's how you would access that value, and then you can do whatever you wanted to do that value. If you want to display it, so like just for the sake of example, currency, I'm going to actually make it so it equals USD for now. So then if I want to say, let's display 10 USD, you can do 10 USD and it shows it like that. And if you want to format it to actually look like real money, you can do that as well, and space, etc. So we're going to get into JavaScript coding more specifically. This is not what today's lesson is about, so we're going to go ahead and stop that. But then back to what today's lesson relates to this. In the end of the day, all of these Xhr requests that are happening on the background, they're all individual socket connections being initiated to whatever port. Like, you know, and sometimes you'll see like you'll have the address and the header actually include a port. It's not always going to be port 80, but by default, if you don't see a port, if you look at the protocol, if it's HTTPS, the port is 443. If it's HTTP, the port is 80. You don't need to know that until you're working on servers, but you will work on servers for ABUF, so it is kind of important for you guys to understand how to read like what port a connection is going to. Now one last thing that I need to mention, and I think we're going to actually be able to close this out just under the hour. So the last thing to understand about the difference between how a browser makes a GET request, right? So one thing to keep, again, remember, when you go to a website like google.com, you are, wow, if I knew how to type, you are essentially still making just a GET request on port 80, but the browser takes all that information and populates it like a web page. But if the GET request gives you back JSON data, or if it gives you any other kind of data like XML data. Does anybody here not know what XML is? XML is not used very much these days. It used to be used a lot. If you don't know what XML is, please tell me. It's important, because if you know what it is already, I'm not going to go over it.
Stone, tell me what XML is.
Okay, so XML was the original like way that you would get data. So like I just showed you JSON, right? XML looked like this. So it's similar to HTML, but it was just markup for information. But as you can see, it's just a lot more data in the end of the day, because everything was kind of wrapped in tags. Like, you know, you can read this, right? I don't know if you guys can see it clear, see this clearly enough. But like, hold on, let me pull a better example here. View image. I hope that that's clear. Oh god, I can't even read that, so there's no way you guys can. Hold on, let me just do tool size large. XML is still used every now and then, you know, and you might end up running into a third-party service that like with something that we do, that you might need to parse XML that data. So it's kind of important for me to just so you just know what it is, even though hopefully you never have to see it again. But just for this, oh my god, just for the sake of covering it. So XML, like if you kind of look at how this is laid out, basically this is a the main category name is like going to be complex type, and then the next is sequence, and then everything that's between these element tags are just this element in the sequence. So in JSON, something like this would look a lot easier to read. It will look more like, I'll just kind of quickly write it out. It will look more like this, like complex type equals, and then you just have open close bracket, and then you just tab forward. It'll be like sequence, and the sequence will be an array, and the array elements, which is all the individual things in it, will look like par graph. Is how it says it over there. Par graph text, and then the next one would be, whoops, simple text field. You get the point, right? So this is like the difference is into like how XML in JSON would look like for the, like, to feed you the same exact data that you're getting from this example. Obviously XML is a whole lot more characters, and therefore the data is a lot larger. So if imagine you're pulling like a ton of information for something, so like say ABUS for an example, we have a game that needs to give you like information on every single user for something, like you're populating like a leaderboard, right? And you need to pull data for like the top 100 leaderboard. So you can imagine how much more data XML would be to give you the same information with the way that XML is formatted versus a JSON format. JSON format is standard.
That's a prettier way of looking at it then.
It's much better, and it's more friendly with JavaScript too, because with JavaScript you can literally just use like this JSON object to parse JSON back and forth from a JavaScript object to just string that you can send somewhere. And I know that right now that's probably a little complicated, but we'll get more into that in the future. But basically JavaScript and JSON are very close together, because the way that you write a JSON, the way that you format JSON data is actually the same way that you would format a JavaScript object data. So it's like, essentially it looks the same. So it's just much better to work with. It's easier and cleaner to work with. But you might still see XML in the future, so just be wary of that. And if you guys are ever doing something with XML, like obviously I will help and all that stuff. You don't have to worry about it too much now. But so those are the different kinds of data. And then the other way that you might receive data from a backend, if it's not formatted in JSON, if it's not formatted in XML, it might literally just be raw data. It might be something that looks like for example, you might have something that looks like this. And I'm just gonna use the same examples from before. So this would be like ID, name, and you just gotta, that way you gotta have like some kind of documentation to know that the first thing is gonna be the ID, the second thing is going to be the name, and then the third thing is gonna be the key. And then once you add encryption on top of that, then the data obviously is unlegible. You can't actually read what an encrypted data looks like. Let me see if I can find an example of an encrypted. The encrypted data looks like this, if you can kind of see what I'm showing you. It's meant to be obviously not legible at all by anybody ever. And then you need...
We used to get this in downloads when we would download bootleg games. Some files in the game would have this.
It's basically encrypted data.
Eligible, yeah.
It doesn't mean that there's nothing there. It just means that whatever software that's supposed to read this knows how to decrypt it before it reads it, basically. And if you're trying to sniff out packet data sent on a secure connection, HTTPS, that's what it looked like. Like you can't actually read anything. But then once you decrypt this, you might have XML, or you might have JSON, or you might have something that looks like this. And then once you decrypt it, then you can work with it. And we will be dealing with encryption too. Like, you guys don't have to worry about it too much, but we will definitely be dealing with encryption. I'll probably be obviously writing like the encryption functions for everything, but you guys will never actually have to try to look at data like this and try to figure out what's going on. But if you're ever like working on something and you see this, then you should know that the data is encrypted, and you need to figure out how to decrypt it before you can actually do anything with it. If that makes sense. But that, I think, is a pretty good overview of like how socket connections work. When a web browser initiates a socket connection, whatever you get back is just one response, and that's it. And then the connection is closed. Like your connection doesn't stay open. So like when you go to google.com, you're not connected to Google. Like you literally just initiate a connection, get the information you want, and then the connection is immediately closed. But when you have like a game server or any other kind of server really that you make a socket connection, then that connection kind of stays alive. So like if you guys remember what I did with the broadcast panel, you had the ping on the top right. So basically we would make a connection to my server, and then anytime that something was updated, like if I pressed a button on my dashboard to update like what series we were on, and I think you all kind of remember going through that, it would go ahead and send that update to every client connected to the server that was connected to the dashboard. So like say if this one on the left here is Brass, and the one on the right here is Nora, and then I had a different client connected to the server. If I pressed a button on my dashboard, that client will go and send a post request to the server, and then the server would update the data, and then it will fire an update to each client, because it was like a live socket connection. So you can send information to the server like instantly, and the server can send you back information instantly. And when you send something to the server, it might look at what you send and respond immediately. So that's just essentially how client to server communication works. Now, to keep a socket connection alive, you need to do this thing called a keep alive, because if the server doesn't receive anything from the client in like whatever timeout you set, usually it's 30 seconds, it's going to assume that that client no longer is connected, and it'll just close that connection on the server side. So say hypothetically we're all using our URLC broadcast dashboard, and then Brass connects to the server and he's like looking at the cards, then he just closes his browser. Now because he just hit that X button, there's no way for the server to know that he did that, because we didn't actually like send something to the server saying close my connection. We just closed it. So once we initiate that connection, every I think I had set it to every 10 seconds, Brass's thing is gonna send a message, and the way I actually made the message name ping, it would send ping, and then the server would send back pong, because essentially you're playing a ping pong game back and forth to make sure that that client is connected. Now, before I sent that connection, I would check what the time was on the client, and then when I received the response, I would check the time again, and I would compare like when I received the response versus when I sent the response, and that is how you calculate ping. That's how you know what the delay in receiving that back and forth is. So that's how ping is calculated, for those who don't know. It's very straightforward, basically. And I think that everybody had a ping of 100 because WebSockets are shit. And that is basically about the minimum. So if you have 100 ping on a WebSocket connection, like one that's running on a browser, that is like pretty much a perfect connection. But for games, like, those who play Rocket League, that if you really want to have a good game, your ping's got to be like 45 or below. Anything above that, you're probably lagging a little bit, and that goes for any game, really. So, like, if you play games and you see, like, sometimes you're looking at somebody and they're not where they're supposed to be, or they're, like, glitching around, it's because not only is, like, when they move, that movement has to get sent to the server, and then the server needs to send it to, like, all of the clients connected. Now, like, a game like Ark, for example, has a lot of logic to, like, only really care about things that are happening within render distance. So it's not like if you're sitting in oil cave and you move, like somebody who's like
From the finish. So how much you cut the attitude?
really
Nora
far
said,
away,
pause.
they're
Her
not
Discord
gonna
cut.
see what you said. What was that?
Nora said, "Can you pause for a second?" Her Discord cut.
Oh, okay, sorry. I'll wait.
Don't be sorry. It's not your fault, Zone.
Hi, Nora.
I'm back.
Welcome back. Just so I know, so what was the last thing you remember hearing?
Right before playing ping pong.
Ping
with
and
the
pong,
directions.
and then you cut out for like a few seconds, and then I heard Rocket League, and then I totally like got disconnected.
Okay, so I was just talking about like how pings are calculated, like and I'll just really quickly go over that again. So like when you send, every socket connection needs to have a keep alive running. I think you got that part right. The keep alive where you gotta send it something and you wait for it to get it back. So to calculate ping, you're basically just recording the time in which you sent the message, and then once you receive the response, you're comparing that time to the time in which you sent. Like so say for instance, I send a request at 4:59, like on the dot, and then I get the response back at 5 o'clock on the dot. I know that it took a whole entire minute, so the ping is going to be like a ridiculous amount of milliseconds. Obviously, in that case, the connection would have closed before you received anything back, but that's just like an example of how ping is calculated. And I think the Rocket League example was just me talking about how WebSockets traditionally, nowadays anyway, so far, 100 milliseconds is the best kind of speed you're gonna get from them, ping wise. But like some for games like Rocket League and games that you need to have like a really fast acting live connection, it needs to perform better than that. So like they perform better than a WebSocket. But the reason why a WebSocket is so slow is because you can't have an unsecure WebSocket anymore these days, and there's all kinds of like security protocols that the browser needs to do, and it needs to encrypt and decrypt all the fucking information. So 100 milliseconds is just about how long it takes. When if you're playing a game like Rocket League or any game that you like, a FPS game or whatever, those connections are pretty live. There might still be encryption, but it still handles it a whole lot better and a lot faster than a browser would. Not to say that WebSockets won't get better in the future, but 100 milliseconds still is pretty good for web-based games. Yeah, so when you like think about games like Agar.io, and things like that we play, there's always that 100 millisecond delay with everything that's going on, because when the client, like, so if client 1 does something, it needs to go and tell the server what it did, and then the server needs to tell everybody around that needs that information what it did too. Then it needs to update there. So like it's not ever going to be completely instant, at least not with today's technology. And that's basically it. And I think that we're just at 5 o'clock. That closes the hour. I feel like this was a pretty good overview of socket connections in general, and kind of explaining how just about anything in the internet period uses socket connections one way or another. Does anybody, as I close this off now for real, does anybody have any questions, as we're literally about to wrap up otherwise?
Okay, I'm back. Did I miss anything?
You can just go ahead and watch the VOD on Twitch, I guess. I know you're joking. No, but I think that it's really good that we do have this VOD on Twitch. I don't expect you guys to go back and watch this one.
What is your Twitch?
Oh, I guess a good question. I guess that's important. It's twitch.tv/cynamicfix, all one word. I'll post it.
I was like looking around and guessing one, and I did Cynamic, but I put the D on it.
Yeah, so like I mean, I just decided to keep this name because like it's the, oh my god, it's the name that I used to use when I was like doing videos and content creation for the game. I gotta change that to be like a logo of the company or something. I don't like the interesting thing here is like I don't actually expect viewers on this channel at all. This is really just for you guys, but you never know. I mean, if we actually end up getting people interested in what I'm teaching over time, then I don't know. We could actually do something with it. Oh, Brassy boy, Brassy man, new follower.
Hey!
Fix. There we go. But All right. I mean, that kind of covers it. If nobody has any questions, we'll wrap it up here for the day. Like once when we do this again, and I think we'll talk offline here after I end the stream. But the next one, we will actually go ahead and start getting into everybody's coding environments and get everything set up, and that's when we're going to actually start talking more about the code that you get back from these socket connections and going into HTML, CSS, JavaScript, and all that stuff. But I think that you guys tell me if you agree, but I think that it is definitely important to have an understanding of how all that code is fed to you in the first place and how all these connections work in the first place before you can start actually coding, because depending on what you're doing, understanding that helps a lot when you're debugging issues and things like that. Like, so say for instance, you are trying to do something, like say you're trying to like make a request to populate something, right? And you know that your website loads, you get information, like you're actually seeing your website load, but whatever, like you looking at that network tab like that I showed you in your developer tools, and the request that you're sending out to get information from a JSON file is failing. So you know that the problem is not like the web server that's running, that's sending you the initial information. You know that something's wrong with the request that goes afterwards. And if you didn't have the like, I know that this is all new to everybody, so I don't expect it to be like natural right away. It's going to take some time for all this to kind of like really feel like to really sink in. But as you're working with things, I believe that this session is going to kind of come back in your heads a lot as you'll understand more and more of how it all relates to what we're going to be doing.
For sure.
So no questions. I will go ahead and end the stream if there are no questions.
Okay, so HTTP port is always 80, HTTPS is 403.
443.
443. And then HTTPS is just a more secure version of HTTP?
Pretty much. I mean, it is a secure version of HTTP. HTTP is not secure at all. HTTP is just raw data going back and forth. AKA unsecure, basically. Anybody else? Any other questions? I just heard my wife say no questions from the baby monitor. I mean, you could unmute yourself.
It's been so long since I've heard Flo through Discord.
Babe, can you unmute yourself and say I don't have any questions, please? No?
Wow.
She's not gonna.
It's like she forgot us all from a year.
I haven't even ever got to meet her, and
it's like she forgot us all.
I was so excited.
Oh look, it's Javi.
Did you never play with her in EU stocks?
No, I don't think. Yeah, she did actually. She did play for a little
No, yeah,
bit.
she did because I spoke to her in it.
Yeah, so we are wrapping up this session here. I'll go ahead and close the stream right now. And until the next one.